Welcome. Ahlan wa sahlan in WFES. First day, I'm here at Sungrow's booth talking to them about the new technologies around the region. I have with me Dr. Soo Goh, Grid Technology Director. Welcome, Doctor.
Thank you very much. Thank you.
How excited are you to be in WFES this year?
Well, honestly, I'm so exciting to see such a big event here. And I'm standing in the Sungrow booth here to see all of the equipment being actually displayed on the booth here. And see all the new technology. I'm so exciting. Really. I cannot express my happiness, and also I just say too exciting to see all this new technology coming up.
Sungrow has had a huge contribution in this region, and I'm very happy to be talking to you today. I have a lot of questions, and I'm going to start with something that's becoming very popular, which is the establishment of a completely independent microgrids for industrial applications.
Yeah.
How did Sungrow achieve any advancements in terms of black start technologies, and what can you tell us a little bit about that?
Yeah, this is an excellent question, right? Historically or in the past, the black start is only about energizing the deck bus bar or the deck systems, right? But in Sungrow here, we have moving from a simple voltage, established voltage system, but to a fully true grid forming capability and forming technology. This is a new kind of a technology that we adopt. This technology actually using the virtual synchronous generator functions, which mimicking the actual synchronous machine behavior, right? But in the static way, in the power electronic way. So what it do is actually provide a very fast response to any disturbance in the system as well. So it can provide the response within the 5 milliseconds. During the startup of the black start, when the power is actually from zero during startup up, right? This fast response from the synchronous generator can actually provide the inertia immediately wherever any step change in the system. So when you're ramping up on the voltage, you can actually very reliably address these frequency issues and also the inertia issue from this black start, which is offered by the grid forming technology. Secondly, what we actually offer here is zero voltage starting capability of the black start technologies. Like conventionally, when we're starting the microgrid or the system, the key challenge here is the inrush current from the system. With this zero, what we offer here in Sungrow here is actually we're doing this zero start technology. So what we do is actually we're ramping up the voltage from zero, increase it slowly, gradually. In this case, then we can actually eliminate the magnetizing saturation of the system, which actually provide a very stable increment of the voltage during the ramping up stage, right? In this case, we can actually remove the issue, the challenge of the magnetizing inrush problem. Thirdly, from the practical side of it, we have implementing this technology in the Middle East here. In one of our recent project, which is a 1 gigawatt project, right? We have actually using this technology to commissioning the projects without the actual grid support and also the voltage from the grid as well. From here, we're actually using this black start technology to energize the local network to start the commissioning even before the commercial COD time. Yeah.
That's brilliant. Well, building on this, it all came from the hybrid part. Mm-hmm. Hybrid inverters of Sungrow have been in this region for a very long time, and a very reliable product that helped this industry to actually move towards the hybrid solutions.
Yeah.
How do your latest hybrid inverters ensure a seamless transition between grid-tied and island mode without impacting the critical loads? You have some critical loads like data centers or large-scale industrial plants. How does this new product help with this transition smoothly?
For the very sensitive load like data centers, right, it's actually the fast is actually not actually enough. So what we're looking for is a seamless transfer for this load as well. In Sungrow here, what we offer here is the sub-cycle transfer. The new grid technology and also the steam cell technology, the grid forming technology, has a capability to actually pick up the load and respond to any step change to the system within 10 milliseconds. So most of the time, it can actually provide the response within 5 milliseconds, right? But we say 10 milliseconds, that's for sake of the just to give it a bit of an allowance as well now. Another thing is the handling of the actual industrial loads, right? In our system, we have a capability to provide the 100% unbalanced, 100% of the phase unbalanced, right? So in the most industry, some of the loads is actually single phase, and they are not perfectly balanced across the three phase, right? If we're using this new technology, we are capable to provide the 100% of the unbalanced single phase faults and supplied it at the same time as well. The third one is the magnetizing inrush as well. As we just now saying, the new Power Titan series, right, has the capability of overloading at 150% for 10 seconds. This attribute is so critical in terms of providing the inrush current to the system. That means you can allow for more inrush current in the system. That you usually, if you don't have this system, usually will actually cause the tripping of the protection system as well. So this is actually very, very critical. Another thing is the thermal stability here. With the new Power Titan 2.0 and also to Power Titan 3.0, we have utilized the liquid cool PCS and also the liquid cool battery cells as well. So this liquid cooling system be able to limit the difference into the temperature between the cell within 2.5 degrees as well. So this actually ensures the battery always discharges at its most optimal temperatures. Yeah. So from all these things, all this together, we'll be able to provide a seamless transitions and to support the AIDC load or some critical load in the system.
Well, AI data centers have been a big deal in this part of the region, especially here where there is plans to build some of the biggest AI data centers in the world. These centers consume immense amounts of power and they require very high reliability. I want to ask a little bit. You talked about the OnePlus X 2.0 and the Power Titan 3.0. I would like to know how these two products are going to contribute to optimizing the power usage effectiveness for these facilities.
Yeah, of course, yeah. So to address the immense power that required by the AI DC or the AI data centers, right? We need to look into from the different perspective as well. So in the AI perspective, every watt that you spend on the auxiliary power or not the the cooling, right, is not being used for the AI compute. So what our strategy is actually to minimizing. The first one is actually minimizing the auxiliary power consumption of the systems, right? In the Power Titan 3.0, we have breakthrough using the silicon carbide PCS, right? This silicon carbide PCS actually achieving the conversions efficiency of 99.3%, which is very, very impressive. And more importantly, it has actually used the AI bionic thermal balancing technologies, right, which actually managing the temperatures in the cell as well. Okay, so unlike the traditional air-cooled battery energy storage system, this liquid cooling system restricted the temperature between the cell and not more than 2.5 degrees C, right, to keep the balance of the battery, the temperature of the battery. Also, this actually reducing the auxiliary power consumption of the system by 40% compared to the average industrial loads. This is from the Power Titan 3.0 perspective, right? When we're looking into the OnePlus X 2.0 inverter, it is a modular type design, so it can provide the granular power management, right? So what does this mean is actually when the data center loading is actually ramping or fluctuated between the training and the inference status, right? We can dynamically activate and deactivate the module of the individual 800 kilowatts inverter, right? So what it actually do is actually ensuring the active inverter is always running at its optimal peak efficiency, rather than we rely on the big centralized inverter, which always running at the half or partial load condition, which is not that efficient.
Very interesting. Well, I also would like to understand and know what competitive advantages do you offer in terms to manage the unpredictable power surges that come from data-intensive processing.
From Sungrow, we have actually offered a lot of competitive advantages, but there are two key advantages that I can actually mention here. One is actually from the energy density perspective. Secondly, is from the redundancy perspective, right? We talk about the density first. The Power Titan 3.0 actually packs 6.9 megawatt hour of the energy into a 20-foot container, right? And for the data center where the land is actually so costly, and in the high price as well. This offers the highest energy density rating and highest density per square foot, right? In the market, which is a huge advantage to the AIDC data centers. Secondly, if we look at from the redundancy perspective, right? With the 1+X 2.0 modular design, if one of the modules actually fail, the remaining module will actually continue running and working seamlessly without any issue. And it's only taking us for 1 hour to replace that the 40 unit and replacing with a new unit. So this ensuring the 99.999% of the availability that required by the AI DC data centers.
Well, speaking about data centers, we have to talk about energy storage.
Yeah.
Speaking about energy storage, we all know the challenge we have in this region, which is the extreme ambient temperatures. So I want to ask you, how does your intelligent thermal management technology leverage AI to predict thermal behavior and mitigate risks before they escalate?
Yeah. Well, in this region here, where 50 degrees Celsius is the new normal, we treat the thermal management not as a reaction to the heat, right? But we actually treat it as a predictive science. So we achieve this through the AI bionic thermal balance technology and also the hardware breakthrough on the Power Titan 3.0 platform as well. Now, we're looking into from the AI-driven predictive perspective, right? The AI that we're implementing, which is the AI bionic thermal balance technology, has a capability to predict and do the pre-cooling functions. So what it do is actually the EMS energy management system is actually analyze the load profile and also the weather forecast in upfront, right? And then it predicts the high load discharge at the noon. For example, the highest temperature during the peak temperature during the noon times, right? And then it pre-cool the coolant fluid in the system and getting ready for that peak hour. Okay, so this effectively increase the effectiveness of the thermal inertia in the system, and before it hit the heat wave is actually hit. Now, secondly, it's actually having this kind of a smart mode switching technology as well. So the AI is dynamically switching the cooling strategy or thermal management strategy subject based on the cell temperature and also the ambient temperature is measured as well. So this actually prevents the overcooling of the system, which usually consume a lot of auxiliary power from the system. By reducing this auxiliary power, also the energy overhead, right? By reducing this power required for the excessive cooling, we can actually increase the efficiency and also reduce the power consumption by 40% compared to the conventional or traditional industrial figures.
And what engineering measures does Sungrow or the system do in order to avoid thermal derating, maintaining full power output even in outdoor temperatures reaching the 55 Celsius?
Yeah, some of our competitors start derating at 45 degree or 50 degree. In Sungrow here, our Power Titan series can actually achieve the 55 degree without any derating and providing the full power output from the system. We achieve this via the 3 engineering measures. The first one is the implementation of the silicon carbide PCS. This is the game changers. By switching to the silicon carbide PCS, right, and Power Titan 3, we actually increase the efficiency of the system to 99.3%, right? Now, higher efficiency means there's less heat generated from at the source. Now, which is the primary reason why we can actually achieve the 55 degree without any derating. Secondly, is the precision in the liquid cooling as well. Now, we don't just cool the container. We cool the cell, the battery cell itself, and also the PCS. We use a liquid cooling PCS and liquid cooling cell. This actually efficiently maintains the temperature difference between the cell within the 2.5 degree, right? So that means we can actually eliminate the hotspot in the system. This hotspot, which will usually triggering the early derating logic of the system. Yeah. We can eliminate that completely. Finally, is also from the design perspective, from the compartmentalized thermal design, we actually split the battery cells from the electrical compartment as well, right? So due to this isolation here, the heat generated from the PCS will not be able to bleed into the battery compartment. That means the battery can always running at its optimal thermal characteristic or thermal window, regardless of what its ambient temperature is.
Yeah. Well, this is very brilliant. It's always a pleasure to talk to Sungrow, to see what's new in the industry. We look forward to your contribution more and more into this part of the work. And I'm very happy to be here with you, Dr. Goh. And we look forward to a promising WFES this year.
Absolutely. I'm looking forward to actually see all this excellent new technology coming out from Sungrow and given back to the industry as well. Yeah.
Thank you very much, Dr. Goh. Thank you very much. And let's wait for what's going to be next for Sungrow this year, inshallah.
Yeah.
Thank you.
Thank you very much.